Thank you so much. It's my second talk in PyCon Ireland. I come from Belgium. I'm not a native speaker, and I'm a little bit stressed because I'm not fluent in English, okay? If you see an error in my slide, don't worry, you can tell me the issue in the whole because it's my first presentation about CPython in English, okay? About this topic. This talk is just based on my previous talk that I gave in the last year about how to explore the Python interpreter, how to start with the development of CPython. But I wanted to continue this adventure in CPython. And for the next step, that just what's a bytecode and how to interpret it, okay? Firstly, I'm just Stephane. Okay, Stephane Wirtel with my last name and the rest. I'm just a small contributor to CPython, just a small, when I have time, okay? Just for the fun, I received a small contribution, an award from the PSF for my contribution in Python, in Belgium, and for Python, and for the Python FOSDEM, biggest event in Europe. 500 people in the room. And I'm also a member of the PSF and, of course, of the Raw Python Society. The bytecode, what's that? In French, qu'est-ce que what's that? Just that. The bytecode is just some instruction to follow. Okay? Used by a virtual machine. You can see virtual. Why? Because yesterday I was in a restaurant and I am the virtual machine. Firstly, say hello, hello. Secondly, set the value to the command. Fish and chips, please. Of course. Order the command. Just prepare the money. Wait for 5 minutes. Receive the command. Maybe hit it. And pay the restaurant. It's just a bytecode, okay? Yes, it's a bytecode. But in this case, it's just, I'm the human. I'm just the virtual machine. It's just an example because sometimes we have some beginners in the room and I'm not sure that you know what's the bytecode. So, I'm going to explain how to convert the Python code to the bytecode. Okay? We have seen a small example with the restaurant and me. Now, I'm going to explain from the developer, me, or you, from the code, we will use the Lexer parser, just in the interpreter, the ST, the syntax tree. We will generate with the compiler a bytecode, and this bytecode will be used by the interpreter. You can see the different bricks inside the interpreter. A small example. I have this expression. I don't know why I like it, but I like this expression. 2 plus 2, just that. With the Lexer, I'm going to get a list of tokens. You know that. In computer science, you have learned that, okay? That's not very difficult. We have a string. We give the string to the Lexer, and Lexer will give a small signification for each word or each word in the string. We have the signification. Now we have the parser. From the parser, we will give a structure to these words. Okay? In this example, we have a module, we have a body, we have some assignation, and the rest. Okay? It's not the topic of this talk. Of course, we have the compiler. The compiler, we have the source code, and we get the bytecode. Just that. Okay? But I don't want to explain the bytecode here. Why? Because we have another section just for that. The bytecode, what's that in reality? A compact code. Maybe 1 byte. Because in a new version of Python, Python 3.6, it's not a bytecode, it's a word code on 2 bytes. 2 bytes, sorry. Okay? It's an instruction to follow, say hello, etc., etc. But it's an intermediate representation of your code, okay? And really used by a virtual machine. A small example. The signification of the bytecode is here. In this example, we have the bytecode from the previous expression, 2 more 2. You have the different value in the file, in the bytecode. For example, we have load const, return value, store name, and load const, as argument. This value will be used in the PyC file and by the interpreter, but I will come back later. About the PyC file, it's just a compiled version of your source code, okay? We have the source code with a text, and we'll get a binary with just bits. Example, print hello, hello. Here is just the Python code. Here is the dump of the binary file. Oh, I like, sorry. Yeah. Okay, can you read that? No? Ole. That's very funny. No, I don't like it. So sometimes you can try with this model to debug, to disassembly the source code, and you can get some information. You see the lines on the bottom, the disassembly section. You have the load name, load const, etc., etc., etc. But in the PyC file, you have some information, very useful information. Firstly, you have the magic number. You have the structure on the beamer. The structure of the PyC file. You have the magic number, you have the timestamp, and the size of the header. Header just the size of the file, in fact. Why I would like to explain that? Because during this week, I just implemented a PyC parser in Go because I wanted to learn the PyC file format. And why in Go? Because there is PyPy, and I would like maybe create a Go Python just for the fun. So with that, I can try to understand the PyC file format. Firstly, the first section is just for the magic number. Magic number is really interesting and will be checked by the interpreter to check if a file has the right version of Python. Okay? I'm going to explain that. We have the magic number in green. You see maybe, no, yeah, here you have this part. This part is just the magic number. The magic number is the version of Python, okay? The timestamp is just the modification time, the Unix modification time of the file, the py file, not the PyC file. And for the rest, that's just the header size. And of course, you can see the other bytes. For the magic number, it's just, as I said, an information based on the version of Python. For example, you know that when we have a new version of Python, we have a new number, new magic number. From this information, you can detect the version of the PyC file. Okay? And I'm going to explain how to compute that. Okay? We have the number, in this case, 3350. Yeah, 50. And I'm going to encode it in Little Endian. We'll add some /r and /n, and I'm going to give the x value. This value will be checked when you will read a PyC file. For the timestamp, there is a signification for that. The timestamp is just the date when you have the modification time of the P file, okay? This information, the magic number and the timestamp, will be checked by the interpreter. If there is if the timestamp is not correct, it will regenerate and recompile the file, okay? That's the reason why you don't have an issue with a new version of your Python file and with the PyC file. So, about the structure of the PyC file. we have the marshalling. When you read the source code of Bytecode or this, you have the Marshall module, this Marshall module. In fact, there is no documentation about this Marshall module. Nothing. You can try. There is one documentation, it's just the source code of Python. No. This format is just specific to Python. There is no standard for that. Okay? Maybe in PyPy, but I'm not sure. Secondly, the marshalling will be used for the storage of the list, the dict, the set, the frozen set, the tuple, the string, long, pylong, etc., etc., etc. Okay? Example. It's a binary file, and when the parser will try to parse this file, the a.pyc file, it will detect some byte. One byte has a match with a tip. For example, for the known or just a false, you have the N or F. Okay? An example with your code. When you have a code in your Python file, you have just the packet for the code object. The first byte is just the type. Okay? If you have a list, just before the list, there is one byte to explain, oh, okay, this byte is just the byte for a list. The next bytes will be for the list, the content of the list. Example with the code. Here, E3 is just the value for the code. The rest is just the signification of the code object. You can match this packet dialog with this binary file. Okay? I have another example. For example, you want to store a tuple in the a.pyc file. You have a byte array. The first byte is just the type. It's a tuple or a small tuple. The difference is in the size of the tuple. The size is encoded on 1 byte or on 4 bytes. Okay? You have the size, and in this part, where's my mouse? Here. You can find some other object, tuple, list, dict, and the rest. Okay? So, for a string, first byte is just the type, the rest the size on 32 bits, and the rest just the content. So, today, I have developed a small tool to explain the content of a a.pyc file. You can see on the left the offset in the file and the value. You have the minimal header, that's the timestamp, the magic number, and of course the size. For the next offset, you have the type of the next part of the file. In this case, that's just the type code. And in the type code, you can see that you have the type code. You have the argument count, the keyword only argument count, num size, tag size, and the flags. And here you have the bytecode of Python, just that. It's not a big array with some string, it's just a byte array with some values. Okay? Yeah. Now, maybe we will discuss about the virtual machine. A virtual machine just has some requirements. Firstly, the bytecode, of course, the stack, some stack, some frames, and the core stack. Of course, some other details, but I don't want to go in the details. I can write a book about that, I think. Now is the... So, about the bytecode. I have my example. X equal hello, Y equal word, a print X more empty, a space more Y. From this example, I use this example because the bytecode will be really simple. For example, I think that you can learn, understand load const store name, load const store name, load name const, and the rest, a binary add. If you know the assembly language, it's similar, okay? Yeah, just that. I don't want to explain the load const because in the next section. A virtual machine is just a stack. Okay? We have a stack, we push something, we pop something, we push something, and I can continue during 1 hour. Okay? An example. I have an empty stack. I'm going to, a custom bytecode here, I'm going to add one value, a second value, a third value. And after that, I'm going to remove. I have an issue. And there, no, let's go. For the add, I'm going to pop the two first elements from the stack, two first, and I will add a new value. It's just the addition of the two first items in the stack. For the next bytecode, it's just sub. I'm going to take the two items from the stack, we'll compute the result, and push it on the stack. Okay? So, a frame. What's that, a frame? A frame is just an information, how can I say that? An envelope, yeah? An envelope where you have the bytecode, you have the code object, we have the code of your function, and you have the locals value, variable, the globals, and the rest, and the constant. This frame will be used by the interpreter each time that you will create a new function or when you will return from a function. Okay? In fact, it's not me. The frame will be created and destroyed on the fly. When you create a new function, automatically there is a frame. Okay? There is a corresponding between each call of a function. And, of course, a frame as an object, a code object. For the call stack, it's just an example. We have the foo function. This foo function will be in the bottom of this stack, the first element, okay? When I'm going to call the foo function, I will use the bar function. This bar function will return a value, okay? When I check, we'll have the main function, the main module. This one will call the foo function, and the foo function will call the bar. And in fact, in the call stack, we will push some new frame for each call. Okay? So, inside the evaluator, we have the virtual machine with the bytecode, with the stack, with the frame, and the rest. Inside the evaluator, firstly, we have the source code. We have the bytecode. Just the small example of the previous slide. But I'm going to explain each bytecode. Explain? No, just the sums. Okay? I don't want to see you between sleep. No, I don't want to sleep. Sorry, I'm not fluent in English. Inside the evaluator, we have the load const. Will take a number, an argument. The store name will take another argument, etc., 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 etc. In this case, I prefer that you read the reference of the bytecode for the bytecode. Okay, I'm not a dictionary. But inside the evaluator, we have the C code. The C code, for example, when we try to load a const, we have a const is just none, 1, 2, true, false. Okay? This value will be loaded from the constant of the bytecode. In this slide, where is that? Here. Come on. Yeah. Yup. That's the constant. Okay? Load const will load this constant. Okay? For the load name, in this case, that's just the print function. So I come back to my slide. Oopla, sorry. Yeah. For the binary head, the bytecode binary head, the interpreter will check if we have two Unicode string, okay, two Unicode object. If it's the case, we will concatenate them. If the values are not Unicode, it will create an addition. We'll add 1 or 2, okay? For the pop top, just it will pop the values, the values from the item, the last item from the stack, sorry. And for the return value, it will try to get the last value from the stack. It's not really interesting, but do you see that? The Y return can have some values. It's an exception, it's a return, a break, a continue, a yield, or just nothing. Okay? So the evaluator is just a very big function. Very big function. 3,000 lines of code. That's very funny. When you want to debug it, yeah, why not? Last point. Welcome to the CPython world. Yeah, it's since 2 weeks I was reading the source code of Python. So next point, just for the fun. I have implemented that in the virtual machine of Python. When you execute a code in your in Python, you can have the bytecode. Okay, I'm going to show. Hopla. X. That's okay? There's nothing. Okay. Okay. And now I'm going to add a feature. Sorry, I don't see. Just that. That's fine. And I think, thank you. If you have a question, I will be outside. It's not very funny. You won't see a unicorn on the slide just because it's CPython. When you see a unicorn or funny stuff, you can tell me. Okay?
We have some time for questions if anyone would like some. Yes.
Thank you for the talk. I have 2 short questions. One is the pickle format the human-readable version of the PYC file? And the second one, are strings limited to int32 in size?
Can you repeat, please? I'm sorry.
So the first one is the pickle format, the human-readable version of the PYC file.
I don't know.
Okay, no problem.
I don't know. But for the Marshall format, it's just used for the bytecode, for the storage, the storing of the bytecode in a C file. There is compatibility because you can take the PYC file and try to read it on a SUN from a PC. It's not an issue for that. But with the pickle, yeah, you will have an issue, problem, yeah. I think. Yeah. And the second question?
I was curious if the strings are limited to int32 in size.
I don't know.
Okay, because I saw you on one of your slides that they were like size int32, and I was like, is that the limit?
I don't know.
Okay, no problem. Thank you.